Hi, this is Juan C. Martinez. Today's date is 10/07/2018, and this is circuit number 2, and this is for attempt for a letter B. So today's sketch is to have Arduino make 8 LED lights blink by making use of the array LED pin variable to save the values of the LED pins, and use the for expression to make it repeat 8 times. So here we have LED pin variables, int LED pins. It's gonna save the value for 2, 3, 4, 5, 6, 7, 8, 9 values of the LED pins, the digital pins. And so it's gonna be saving a total of 8 elements. Okay, let's jump into the code. Here we have void setup. It says int I equals 0, so it's gonna start counting at 0. It says I is gonna be less than 8, and so I equals I plus 1. Alright, so that means that I equals 0 plus 1 equals going to be 1. Is 1 less than 8? Yes, it is. And so on until it reaches 8. Until it reaches 7. 7 is going to be less than 8, and that's going to be true. When it reaches 8, then it's going to be not true anymore, so it's going to stop there. Alright, and here we have, on this occasion, we're going to be making use of the for loop. So here it says one after another loop. On the previous video, we were making use of the one after another no loop expression, but this time we're making use of the one after another loop. So here was the previous code. This one is no longer applicable to this one. And then this is the one that is applicable to this video. On this one we have that it says void one after another loop. It says int delay equals 500 milliseconds, and then we throw in another variable here. This is delay time 2, which equals 500 as well. Now, was that needed? Not really. Previously I had it made to a different one, but we're gonna make changes to this one to show an example of how that works. Alright, so we have delay time 2 equals 500 as well, and right here we have the for expression. It says for int I equals 0. In that case, it means the I equals 0 is the initial expression. Then we have I less than or equal to 7. That's going to be our loop condition. And then lastly, for our loop expression is going to be the I plus plus, which is another way to say I equals I plus 1. So it's going to start counting at 1. So we have I equals 0 plus 1. So I is 0. 0 plus 1 is going to be 1. So is 1 less than or equal to 7? Yes, it is. So it's going to continue, so on, so on, so on, until it reaches 7. Is 7 less than or equal to 7? Yes, it is. So in total, it's going to be doing that iterate a total of 8 times, because it's going to be doing first a 0, then all the way to 7, which is going to be 8. And then we have here digital write LED pins I high. So it means the total of those pins is going to be high, which means it's going to be on. We make use of delay time, which is the first variable of 100. And then for the off time here, it says for I equals 7, that's going to be the initial expression. Then I less than or equal to 0, that's going to be our loop condition. And then we have I less, and this time it's going to be counting less. So it's going to be counting from what is it called, the 7 all the way down to 0. So I equals 7. 7 minus 1 is going to be 6. And then so is 7 greater than or equal to 0? Yes, it is. And then it's going to go to 6, because again 7 minus 1 equals to be 6. Is 6 less than or equal to 0? Yes, it is. So it's going to continue all the way down to 0. Is 0 less than or equal to, yes, equal to 0? Then it's going to be, it is equal to 0, and that's when it's going to stop. So it's going to do so for a total of 8 times. We have 0 right LED pins I. That's low, means that when it's going to be turning off, it's going to be delayed for delay time variable number 2, delay time 2. Alright, so on this one, that's pretty much all there is for the code on this one. It seems to be shorter since we are making use of the for loop to do all the counting for us. We don't have to use that long code that we were using back here. Back here we were telling it what values to use. We were telling it to use the value stored in the element 0 all the way down to 7. But we don't have to do that. Now that we have made use of the for loop expression, it does the counting for us due to that ending of the loop expression, that it's going to be doing that for us. And then so we are going to go here now that we have loaded the code to the Arduino board. On the Arduino board we're going to move here. We have moved the code to 500. That way it can be a little bit slower and we can be able to express it a little bit better. So we have pin number 2 is connected to the positive side of the LED, the first LED, and it goes all the way up to pin number 9. Pin number 9 is a red wire that goes to the positive side of this red LED, and then we have one grounding wire, which is the black wire. It goes to the negative side of the breadboard, and all that line is going to be the negative, and then that's where the resistors connect, and the resistors connect to the negative side of the LEDs. That's just for what is called safety of the LEDs, so they don't get damaged. Alright, so it's going really slow. That's because we have put it for 500 milliseconds, and that's just to explain how it goes. So it starts from, well, let's wait a little bit. Let's see. Alright, it starts from 2, 3, 4, 5, 6, 7, 8, 9 pins, and then it counts down, just like we have mentioned over here. On this one, it starts counting from 0 all the way to 7, and then on this one, it counts from 7 all the way down to 0. So that's why we can see it here, that it goes from up all the way down to pin number 2, and then from 2 all the way up to pin number 9. That's just because that's how we have set it over here. Now we can make this thing run a little bit faster as well. What we have to do here is just change the values that we had set up here, the variables that we had set. We mentioned delay time 500, delay time 2 equals 500. Let's move it down and to 50. We press CIRC02, which is going to unlock the code to the Arduino board. It says done uploading. Has it really done so? Let's see one more time. Okay, now we have it. We go here and you can see it counts low really fast because we changed the variable of the LED low. See, LED low is the delay time 2, which is now set to 50 milliseconds, so that's really slow, really fast. And then we have delay time equals 500, that's really slow, and that's the time that it's going to be on. So it's going to stay on for 500 milliseconds and then off for 50. So that's why. It goes high really slowly and then low really quick. Alright, thank you.